It'll be worth me explaining this to you, even though I know I'll sleep again. If you're asked this, how many, that's the numerical value, moles, that's the unit, and helium atoms, this is what you're being asked for. So you could immediately come over here and go, some number, and then look at what you're given to work with. You're given a numerical value, and look, no unit. There's no unit there. You go straight to the label, helium atoms. And what you're given, you're going to put on top. Given, that cancels out. 10 to the 21, oh, wait, 10 to the 21. No unit, helium, over 1. If you go through it like that, you look at what you're given, no, what you're asked for, and then you outline it on the right side of the equal sign. Then look at what you're given, and you're paying attention to whether there's a unit there or not. So there's no unit here. When you have one that's missing a unit like this, that's when you're going to use otherwise that number won't show up in it. When I show you what we do next, when we do grams per mole, you'll leave this number behind and we'll barely ever talk about it again for the rest of this semester. The only thing you need to key on is, are we missing that counting unit? There's no unit here. There's no grams, there's no liters, there's not even dozen, there's nothing here. So that's what I'm modeling with this dotted line. So you put that there because that's what you were asked for. You put that there because that's what you were given. If you're keying on this and going, oh, okay, I'm going to need 6.022 times 10 to the 23rd because this is not here. And you're going to put this, we need to end in moles, so it needs to be on top. And then the last thing you're going to do is and now everything cancels out and you'll get the right answer as long as you calculate it right. Contrast that with up here. How many helium atoms? Okay, how many? This is what's going on the right side of the equal sign. There's this, and look, no unit. We go straight to the label. There's no unit there. So this time I'm putting over here some numerical value, dot, 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 dot for the unit. You with me? And then it says, how many helium are in this many helium atoms? Oh, I wrote this wrong. And I don't want a huge number here this time. 1.46. So I wrote this on the right side. There's no unit here. That's the key. And this one says 1.46 moles of helium atoms. So numerical value, there's my label. There's my unit, there's my label. So now I'm writing on top. 1.46. 1.46 moles helium atoms over 1. And now I'm using this, but I'm going to use it flipped over. This time I want moles of helium to cancel out, so I've got the dot, dot, dot. So the dot, dot, dot needs to be on top. Helium atoms. Now here is 1 mole. Now the moles cancel, you end up in the dot, 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 and you get the right answer. You follow that? Those are the only two cases for these simple types of problems where this number comes up. You with me? I did put Davy ionic compounds and stuff in there. All right, so let me show you something else. From the periodic table. This is how we would use the periodic table for most of the semester. Those of you who have taken chemistry before probably already know this, but if you look at helium, the top right here, the 4.00, you can walk right up to the periodic table and go grams per mole. That's what that number means. How many grams 1 mole of helium atoms weighs. That's what's tabulated there by that number. I would tell you, turn that into 4.00 grams helium over 1 mole of helium. Now that I have that, I can write some more questions like this. But 6.022 times 10 to the 23rd isn't going to come up. Okay, so let's read through this. How many equal sign, numerical value, how many grams? Yay, there's a unit. Grams, I'll just say G. Helium atoms. That's what I'm trying to find, how many grams of helium atoms. And down here, I've got numerical value, a unit of moles, and helium atoms. And it's this that I'm going to use. I've got grams to moles there. So I'm going to write this first, what I'm given. I need to end on grams, so it needs to be on top. And moles needs to cancel, so I'll use that the way it is. Sometimes you're going to want to flip it over, but in this case, I want grams on top and moles on bottom. And you can calculate that. It's 4 times 4.91 essentially, and it'll be 3 significant figures. Moles of helium cancel, moles of helium cancel, you end up in this grams of helium. And the key here is, what I'm asked for, I had a unit, grams. And what I'm given, I had a unit. When you have 2 units there, there's no blank. The 6.02 times 10 to the 23rd doesn't come up. You follow that? It only comes up early in the semester where we beat you up about 6.022 times 10 to the 23rd. It doesn't come up much after that. We try to get away from it. That's the whole point of having that unit. And the other way you might get this is I'm just going to swap moles and grams. Now, just like I did these, I had moles here and then no unit. And down here I had no unit and moles up here. Now I've got grams up here and moles here. Now I'm going to flip this over and go, how many moles of HB? I don't usually put the quotes there. Mole R in grams. And now I've just flipped it where now when I read it, I'm going to go, how many moles helium atoms how many moles helium in it. So this is what I'm asked for. Here's what I'm given. Put that on top of 14.7 grams of helium. Now I'm going to use this again. This time I want grams on the bottom and moles on top. So I'll flip it. 1 mole grams. And now 14.7 divided by 4. Keep 3 significant figures. That's how it works. So even if you hate 6.022 times 10 to the 23rd, I just want you to realize if you work kind of mechanically, you can get set up. I realize the math gets tedious with a power of 10. But you can get set up correctly, and then it's just a matter of being able to get through the math. And like I said, vast majority of the semester, this is what we do. We get away from that big number. We stay away from powers of 10 for all we can. And that's the whole point of having a defined number that's this huge. Okay? All right. One more thing while we're talking about grams per mole from the periodic table. Typically called either the molar mass or the molecular mass, the grams per mole, atomic mass. This is the atomic mass of helium. But let me scale this up and go. We're going to write over here. First, let me just say, I'm done with that. Let me get that. So, quick callback. Ionic or covalent? You say ionic?
Covalent.
Not do that to embarrass you. I just want to make sure you're paying attention. All right. That's the formula. Wherever it's feasible and useful, I like to give you the structure. So this is showing the covalent bonds that I talked about earlier. Quick callback here. Here's the Lewis structure of carbon. Lewis structure of those hydrogens. We pair them up. Carbon can make 4 bonds. Hydrogen can make 1. That's what C2H6 looks like, at least diagram. It has a different sort of 3-dimensional structure. But this is all we need for what I'm about to do. So I look at my molecule, and I go, C, there's 2 of them. Hydrogen, there's 6 of them. And then I'm going to go times. If you look at the periodic table, that number for carbon is 12.01. For helium, it's 1.01. So if I have 2 of these, one of them weighs 12.01. 2 of them together is going to be 24.02. 6 of these will weigh 6.06. That just happens to be math that's easy to do in my head. And if I add it all up, I've got 8, 0. The 4 goes with the 6. 30.08, and then go grams per mole. I could have written grams per mole here and then carried it through and written grams per mole, but I just do that in the margin real quick, and then I stick grams per mole on there. And again, I would say write this as 3.08 grams of C2H4 relabeled in 1 C2H4. That's saying if I have this many of those molecules, that's how many grams it will make. And that's why this is useful. We can count atoms by weighing them on a scale. You guys with me? So if you have your periodic table, you can do that.
Why is it C2H4 now instead of C2H6?
Good one. It's supposed to be a 6. 6. Thank you. But now I can do this with that molecule. Now I can go, how many grams of and C2H6 now I should say molecules, C2H6 molecules. C2H6. So now it's not proper to say atoms, I need to say molecules. Are in moles of and then I can flip it over to the other way around. How many moles of C2H6 are in 1.47 grams of C2H6? I'm not going to say molecule again. It's understood what that is. Did I erase all that? I guess I did. But again, I'm going to look at this and go, how many grams of C2H6? I'm going to go equals some number of grams C2H6. So that's that. And then I'm going to write this on top. 4.91 moles of C2H6. I ran out of room there. Now I'm going to use this, 30.08 grams over 1 mole. And I'm going to use it just like it is because moles needs to be on the bottom. 1 mole C2H6. 30.08 grams C2H6. 3 significant figures, 4 significant figures. These ones are exact, so you can ignore them for significant figures. Multiply those together. Moles cancels, you get into grams for this. You with me? If you do it systematically like that, you can't mess up. You guys all right? Do this one. Good, I did that. This one is just the same. How many moles? C2H6 and this time I'm going to flip that over and it's going to be 1 mole on top. And now it's 14.7 divided by 30.08 to 3 significant. What are you guys doing? All right. If you look at the book, let me just get you past this real quick. I think I said this last time, but now that I've actually done some grams per mole, you can stick it away somewhere and never look at it again. You can get that off the periodic table, or you can get 4.00 grams per mole for helium off the periodic table. That's for the C2H6. The book will go through using AMU. In that, the atomic mass unit is for 1 atom, or 1 single molecule. It's a very, 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 very tiny, tiny measurement of mass. We don't use that. Chemists work in labs and we're not physicists shooting particles, you know. So, but it turns out there's a conversion factor that was very purposely chosen to turn the AMU right into grams per mole. This is what we're going to work in. So if you see this in the book or on the ACS test, just go ahead and think grams per mole and calculate it the way you know how to do it, and it's going to be fine, I think. But anyway, I kind of skipped this whole discussion because it's kind of a physicist kind of way to look at things. So this book says AMU a lot, and then later it starts talking grams per mole, but it's literally the same number. This is what I just did, moles from grams. I did it one way. I think what would I add here? Okay, maybe I should. Just so you're aware, I did a covalent I did an individual atom, helium. I did a covalent compound. If you do this with, if you need the grams per mole for a sample with an ionic compound, it's literally just that formula we've been learning. MgF2. In this case, we have 1 Mg, 2 fluorines. Grab your periodic table. Mg is 24.31, but that's times 1, so it's just 24.31. And fluorine is 19.00 grams per mole. 2 times that is 38. Add them up. So if I wrote a question that has this many grams of MgF2, how many moles of MgF2 that is, this is what you would use instead of the 30.08. MgF2. Let me take a quick look at what I've added to D2L for you guys. Okay, it's these 3. Ionic compounds and naming. Invisible. Can't believe I don't have any molarity questions in here. I have to go find them. I have them saved somewhere. But I'll get some of those up for you.